Welcome to section 12.4. This is multiplying and dividing rational expressions, and this is video number 1. In this video, we're mainly focusing on multiplying rational expressions. So here we go. First of all, rational expressions are situations where the equations look a lot like fractions and there's lots of variables in them. However, they can be thought of quite often like fractions. And I know those are our best friend, but we can handle it and it'll be fine. So I like to think about this in sort of a very general way at first. And we're going to think about it in A, B, C's, and D's. If A, B, C, and D are non-zero polynomials, so essentially they're polynomials that don't equal 0, then A over B times C over D equals A times C or B times D over B times D. So we're going to practice this with one quick problem. We have A plus 3 over 2 times 6 over 3A plus 9. So when I look at this, I actually like to think about this instead of vertically like I just did, think about it horizontally. So A plus 3 times 6 and 2 times 3A plus 9. And if I think about it that way, then I'm thinking about it in the way that I multiply with fractions, just going straight from one side to the other. So let's get started. We have A plus 3 times 6. So we can rewrite that as saying A plus 3 times 6. We can also write the stuff underneath as 2 times 3A plus 9. From there, it's easy enough that we can see, oh, I'm going to need to use the distributive property, and so we're going to do just that. On the top, we get 6A plus 18, and on the bottom, we will get 6A plus 18. We have the same thing on the top and the bottom, and that's another way of saying we have the answer for 1. That will be our answer for that particular polynomial. Let's try a couple of more problems with this same idea of essentially multiplying straight across. Here's our next problem. We have 12 times b to the third c squared times 15a squared b over 5ac times 3b squared c. Lots of stuff there, and as I said before, I was doing things from left to right. I like to think about these top portion all multiplied, bottom portion all multiplied. And we know it's all multiplied because we just have essentially invisible multiplication signs all across these. So we're just, instead of reading them as individual fractions, we're reading them as a whole statement up top and a whole statement up the bottom, or on the bottom. So we need to do 12 times 15, which is 180. So there's our first term. I'm going to draw little triangles above that. We have our next term, which is b's. We have 3 b's on one and 1 b on the other, so we have a total of 4 b's. We have an a squared, and our last term that we have is a c squared, and that's all on top. Underneath on the bottom, we have 5 times 3, which is 15. We have our a term, or a variable. We have our b squared, and c for both of them, so we have 2 c's. Now all we need to do is simplify. And so to simplify, we can just look at, see, what is the same from the top and the bottom. So 180 divided by 15 is 12. So essentially I can cross out 180, I can cross out the 15. The 15 will become a 1, and the 180 becomes a 15. We can think about this as simply the fraction 180 over 12 or over 15, and essentially be dividing the top and the bottom by the same number. So we get, whoops, I should have wrote 12 up there. So we end up getting 12 over 1 as we simplify it. I'm going to give myself more room by deleting this, by erasing it all. And so our next task will be to figure out what else we have remaining. We have, on the top we have b to the fourth, and on the bottom there's b squared. So if I look at this, b to the fourth is going to become, oops, I don't want to erase. B to the fourth is going to become a squared, and b squared disappears. As well, on the bottom we have an a term, and we have an a squared on the top, so that actually just becomes a. And the c squared from the top and the bottom both disappear. So our final answer is 12 on the top, then we have b squared, and we have our a term. 12b squared a, and on the bottom, all we have remaining is 1. So our final answer is 12, and I'm going to switch these up. I'm going to put a first, 12ab squared. And I just say that because a comes first in the alphabet, so I'm going to write that one first. So there is my final answer for that problem. Let's try another. We have 5x squared times 3x, thinking of it as a unit up top, over 2y to the third times 2y squared. So let's combine like terms. So we're multiplying like numbers or variables. We have 5 times 3, which is 15. We have x squared and x, so we have 3 x's, over 2 times 2, which is 4, and y to the third, y squared equals y to the fifth. I don't see any more simplification because 5 cannot be divided by 4 without having a decimal. X and y's are in different places from the top and the bottom, so here is our final answer for that problem. So what we need to take away from all of this is be organized. So if you notice, I created little sort of keys or roadmaps to make sure I was paying attention to the right numbers or variables at one time. And then also remember to simplify. If you don't remember to simplify, you're going to have a partial answer. I'd be able to give you 1 point but not 2. You get points for your work, but you wouldn't get points for the final answer. So remember to simplify and check everything. Make sure there's nothing repeated. We don't want any repeats in the top or the bottom parts of our equation. Okay, so if there's something in the top, there should not be that same thing repeated in the bottom in any way, shape, or form. So let's go on to our next part. We need to be able to multiply rational expressions by a polynomial. We have x squared plus 8x times, or plus 15 times 4 over 2x plus 6. So first things first, we need to think about this as being like a whole number times by a fraction. 8 times 1/3. We can rewrite this as saying 8 over 1 and turn it into a fraction times 1/3. And if we do that, then we can do our multiplication straight across and we get 8/3. We're going to think about this in the same exact way. That polynomial is our 8, so we need to put that polynomial over 1, so we essentially develop a funky little rational fraction. We have x squared plus 8x plus 15 over 1 times 4 on top and 2x plus 6 on the bottom. After that, we need to factor a little bit so that way we can get rid of a little bit of fluff maybe. This 2x squared plus 8x plus 15, this information right here can turn easily into x plus 3 times x plus 5. As well, on the other side of that, all of this, we still have a 4. And on the bottom, there's still a 1, and we have 2 times x plus 3. So we have all of that. After that, we can cut the fluff. We can get rid of all the extra stuff. If we look at this, we actually have an x plus 3 in the top part of our equation and in the bottom. And the reason why I can cross out things from one side of an equation to the other side of the equation across that multiplication is if we notice there is a multiplication sign here and a multiplication sign here. So in all reality, this fraction bar can continue straight across without any problems. As well, so after we've crossed out that x plus 3, we now need to look at anything else. It looks like on the bottom we have a 2, and on the top we have a 4. So we can actually simplify that. The 2 becomes a 1, the 4 becomes a 2. Simplifying 4 over 2 becomes 2 over 1. We can handle that. So our final answer for this problem, or at least our almost final answer, our penultimate final answer, we have a 2, an x plus 5 along the top, and on the bottom, we simply have 1 times 1, which is 1. So, finishing up, we can just write this as 2 times x plus 5 as our final answer. Completely simplified. Let's try one more type of multiplication. Multiplying rational expressions containing polynomials. For this particular problem, we can actually do this one of two ways. One way I like more than another. So our first method of solving this is we are going to first simplify and then multiply. The second method, we are going to multiply and then simplify. You'll notice that one of these ends up being a little simpler than the other. This first one, let's simplify and then multiply first. So simplifying means first we are factoring, and then we are simplifying based on commonalities between the top and the bottom. Okay, so we need to factor this top part right here. We have 4d to the third plus 4d. So to factor that, we need to find a GCF, which is 4d. So we are left behind with d squared plus 1. As well, we can then also look at this portion right here up top. We have a 2f. There is nothing for simplification that we can do. However, over here on this bottom part, we have 16f, and again, we can't do anything. And on this lower part right here, the 7d squared f plus 7f, we definitely can simplify that. We can take out a 7 and an f, and we're left with d squared plus 1. This is kind of cool. I'm seeing things on the top and the bottom that can be simplified, that we can cut the fluff. Some of the fluff that I see is this d squared plus 1. That one sticks out like a sore thumb because it's massive. So we can cut that from the top and the bottom. Next, after that, we need to think about what other things can we take out of this. Looks like we can get rid of an f on the top and the bottom. And we can also get rid of a 2. From the 4, that'll become a 2, and the 16 will become an 8. Additionally, we can also, I should have said the 4 can become a 1, and the 16 can become a 4. Essentially, I divide by 4 in the top and the bottom. If I thought that was all the simplification I needed to do, we can then multiply through and see what we have going on. On here, we have a d left over, and we have 2 left over, so we have 2d on the top. And on the bottom, we still have a 4 times a 7 and an f. So looking at all of this, it looks like I actually have a little bit more simplification that I can do. I can get rid of a 2 on top, and the 4 will become a 2 on the bottom. And then we'll have just simply a d on top over 14f on the bottom. So there's our final answer. Let's now look at the second method, essentially multiplying first and then simplifying. And I'm going to scoot over here so I have enough room. So we're going to first multiply and then simplify. We have 4d to the third plus 4d times 2f. So essentially what we're saying is all of this 4d to the third and the 4d, that's in parentheses. So this 2f will have to get distributed into there. So if the 2f was distributed in, we end up having 8 d to the third f plus 8df on the top. On the bottom, we have a similar situation. The 16f is multiplying the 7d squared f, and it's multiplying the 7f. So 16 times f is, well, actually 16 times f is 16 times f, but 16 times 7 is 112. And we have d squared f squared now in there. We have 16 times 7 again, so we have again 112, and we have two f's now, so f squared. That's all we did with our distributive property. So from here, we now need to simplify. We've done our multiplication, we now need to simplify. If I look at just our top formula, if I look at just our top expression, I need to find a GCF. I need to find a greatest common factor. It looks like there's an 8 in each of our terms. There's at least one D, and there's one F. So if I take 8df out of each of these, in this first term, if I take 8df out, I end up with just having d squared. And in this last term, if I take that out, I end up with a plus 1. And I'm dividing this all by something similar down here. Let's find our like terms. It looks like we have 112 in both. There's no d's in both, but there are two f's in both, so we can say f squared. And what remains in our first part is a d squared. What remains in the second is a plus 1. So after that, we can simplify that d squared plus 1, just like in the other version of this equation, we'll simplify out. And it looks like we're also going to take away an f from the top and the bottom, so an f remains in the bottom. And we need to simplify that 8 over 112. So let's think about how many 8s go into 112. So if I were to divide 112 by 8, I get 14. So 8 on the top disappears and becomes a 1, and the 112 on the bottom becomes a 14. And up top, if I were to rewrite this, I have simply d, and on the bottom, I'll end up with 14f remaining. So if we look at our two problems, we were able to solve them both and get the same answer. However, as I was going through this multiplication then simplify format, as I was going through this whole thing, I felt like I was taking up a lot of paper, but then I also was really nervous as I did some of this distributive property here and got this. I was really nervous I was going to miss something. Whereas if I simplify first, essentially cut the fluff right away, be nice and brutal about it, take off all that fluff, and then multiply, I feel like I can do it a little bit more thoroughly and a little bit more focused. So consider that when you actually do your problem. Let's try one more, and I'm going to do the simplify first then multiply method, and you will see once again how this can all work out in your favor if you do simplification first. So if I look at this first part of our problem, we have n minus 5. Can't do anything with that, so it just stays n minus 5. But over here, and actually, almost losing my voice, the n minus 5 I'm going to put in parentheses because we have actually a trinomial over here. So that trinomial, I look at it and I can see that it's a perfect square trinomial, so I can say it's n plus 8 times n plus 8. All of that is multiplied straight across because we've practiced this enough times. And on the bottom, we have n squared plus 4n, so we are going to factor out, it looks like, an n from both terms, so we have n plus 4 times n. And then over here on this side, the n squared minus 3n minus 10, we can simplify that as n minus 5 times n plus 2. Now it's time for us to cut the fluff, get rid of anything extra that we have going on. And it looks like we don't have a lot extra, but we have a little bit. We can at least cut out a little bit of this. So it looks like we can cut out n minus 5 on the top and n minus 5 on the bottom. From the rest of this, though, I don't see anything else we can get rid of. I see some nice factors and things like that that looks like they maybe could cancel, but they really don't. So up on top, we have n plus 8. We can actually write that as n plus 8 squared. instead of n plus 8 times n plus 8, and that is over n times n plus 4 times n plus 2. So this was the simplify, then multiply method. And essentially, to simplify, you need to factor. And that will help you work yourself through these problems. So I know this video is long, however, I hoped it helped. Please work yourself through the homework and see how it goes. And don't forget to watch video number 2 based on division. Talk to you later. Bye.